I'm coming from Bike Life, and later on I will talk a few words about myself and company as well. Then I will start with really high level, touching review of security landscape, and then I will go a little bit and scratching software-defined concepts, how those can be applied, maybe some fresh angles, some fusion of different disciplines. And then I will touch briefly one implementation, one demo we have made, and throw up a couple of other ideas which anyone can exploit. So, first, a few words about me. I've been in the business more than 15 years, in covering different areas. Once in a while, I had to do some programming. I don't do that often any longer. So I moved mostly to the networking and security business, and looking on data center architecture. But altogether, they are tied actually. So one of the disciplines will help another one. So a few words about the company I'm coming from. So some of you may know, some of you may not. Historically, we've been doing a lot of infrastructure stuff. That's not probably that interesting for you, right? You are most of programmers, isn't it? Show your hands. Right. Okay. So infrastructure, it's something that should work, right? We don't care. Then we went a little bit higher up in hierarchy, and we thought how to automate the infrastructure stuff, because usually it's done all manually, and the infrastructure actually we define till the application layer, not the application itself, but anything below that. And then we have developed different tools and products to help those automations which are tied to either infrastructure or some component of those. Maybe the first one is Flow Graph. You may or may not have heard about it. It's a repository for vSphere workflows. So there are certain components which you can reuse and personalize, etc. So if you have to do something with VMware workflows, VMware orchestrator workflows, then you may have a look at that. But now let's get to the point. Where we start is a wonderful report done by Verizon. Obviously there are many other companies who are doing reports, but they are a pretty good one. They are rather neutral, so they are not specifically security vendor per se, although they are heavily visible in that space. They offer services on that. What they say essentially that there is a breaches occurring every day and every minute, and it takes really little time to compromise something. I bet most of your code you write is compromisable. Sorry to say that. And it takes really little. But at the end of the day, we want to capture the compromise and minimize, and at the end of the day, fix your code. But between that, there is a huge time usually, till it's discovered, it's mitigated, and it's fixed. So in general terms, if you just look a little bit wider picture than the coding itself, so the application or the company who is using your code has to be protected somehow or mitigated the risks. So this time here, detection or fixed time, it has to be shortened somehow. This is what I'm going to talk mostly today. So how it's going to happen that this time is so long? And it all has to do with security as a concept. It's used to be, it still is, complex discipline. There are really many variables. There is a human aspect, there is tools, and there is a machinery around it. And that makes the process complex and time-consuming. From the other hand, there is a concept in place which is on networking, it's software-defined networking, which is actually very fast to adapt the changes. It's flexible, it's scalable. So what if we could put those two concepts together and get something out of it? Would that be an interesting idea to exploit? What do you think? No. Okay. So essentially what we thought about is if we kind of take best of those both of pieces of network stuff, security stuff, and add some application stuff over there, we could come up new wonderful acronym. We all like acronyms, isn't it? So how we define it? It's software-defined scopes, network security. It has to do with network, right? That's where I mostly specialize on, but you can have a look on different aspects. So you maybe are mostly in this area, applications, and I will go to that a little bit later, what I mean by applications over here. So in essence, it's very simple, right? Just put something together and something comes out. So why do we do it? And the main idea to get it in this way is to change the mode. So currently in the security field, most of the time, it's workflow management. Fix that, make that change, and there is a huge approval, etc., etc. So it's all reactive. So if something happens, it takes a while till it's fixed. So what if we could make a small change in paradigm and we start not to reacting on things, but we're gonna kind of predict the things. So we basically look forward and think what kind of policies we need to minimize those reactive workflows which are not really giving extra value. They are just eating the value because we have to deal with things. So that's the great idea what we would like to achieve here. So if we could kind of expand those terms a little bit, what we mean and what we want to achieve, how we believe that could happen, is that we get something from each discipline, right? From the networking side, we get pretty good visibility to stuff, what's happening, what is not happening. So we could utilize that. So abstraction, this has to do with abstracting all those different vendors, different pieces and blocks, which are each have different behavior, and abstracting the control plane of those. I will talk about the different planes just in a minute. Abstract those a little bit and give them a common denominator so we can talk to each of them and give them the policy. The automation obviously has to do with automation of everything. So you automate all your processes as a developer as much as you can. Very likely, I hope so. So the same promise is why not to do it in infrastructure? Because you probably heard that if you require some new resources, it takes some time. Why? Because it's all manual stuff. So you want to get that shortened as well. And obviously we want to, in general terms, we want a scalable solution, which is not specifically tied how big it is, as many people we have to put on it. So, and portability of applications has meant as well that that application actually, which control the stuff, they are reusable in different kind of underlying infrastructures. So, is there anything available which we could use to build that? Not everything from the scratch. Sure, there are tens and then maybe hundreds of frameworks and works done in that field, right? What you probably have had some experience with is, I guess, OpenStack. That should ring some bells. Yes? No? No. Right. OpenStack, but it's mostly orchestration stuff, right? It can provision some stuff in rather generic, doesn't go any deeper. Still pretty good orchestration platform, right? Another thing which you may heard or may not heard, it's OpenFlow stuff from Open Networking Foundation. They made quite a nice few years, and that has to do with basic packet forwarding. Here is your packet, do something with it. But there are other disciplines for path control or device management or etc. etc. So there are a bunch of frameworks, and if you really want to get everything in the scope, it will kill you essentially, because there are too many frameworks you have to integrate, right? So what we may need, let's have a simplistic view. When we talk, I probably touched several times different planes, control plane, data plane, etc. So just brief, if you're not networking people, there is a slide for you. So first of all, analogically, control plane is where the stuff goes on. So the real-time traffic, like the cars running through the city, that's a packet flowing through the infrastructure. So that's control plane. But the cars actually can't run by themselves very good. They need some guidance. So this is where the control plane comes in. So analogy could be the traffic guide, GPS, or any other guide. So this is how the cars will run, or people will run the car. Another analogy, plane in it, right? So the planes, they carry the people. This is a control plane, and there are some air traffic control who actually says where the plane can land or where it can fly, right? Simple as that. So if you have a look at different architectures which we can use to build the ideas we had, there are basically two kinds of those. So the first one is hierarchical, very simple. You can see on the right-hand side. So essentially, I will go to the details just in a few slides, but there is your physical infrastructure, and there is your application, and there is something in between which controls the stuff, the controller. Or you can build around your applications, and you may talk to different controllers or different physical devices, depending on capabilities. So this is what we call peer-to-peer model. So they can all talk to each other. It's not strictly hierarchical. So one of the examples to give you here, what could be used in either cases. So this is an illustration of peer-to-peer model, and it's based on Cisco framework. It's onePK, Open Platform Kit, PK. So there are a bunch of services which you can use to direct or control and perform different functions. So there are service sets which you as a developer can use to drive the underlying infrastructure. And the underlying infrastructure, there are various pieces on that. And there is just one common interface. So regarding deployment model, how you can deploy that, it varies. You've probably seen there are several languages of your preferences which you may like or where you are more proficient. So the one you can use, obviously. So based on deployment needs or application needs, it could be deployed on the device itself if it's really a time-critical management task or forwarding task you're going to control. Or it could be more generic, slow-moving or slow-changing process or flow which you can control from outside, and then you control different devices in more or less hierarchical model. So both of those models, deployment models, can be utilized in this platform. Alternative model is to build it in hierarchical way, the classical way the SDN is built on. So it's mostly following the data plane model below there, where the physical devices are, and there is a controller on top of it. Controls, give the policies what this infrastructure should do. And control by itself actually is also a dumb piece. All the intelligence in this control program, which you as a developer actually develop based on your real need, what you want the underlying infrastructure to behave. Right. And there is a industry association or industry kind of coalition who have put all the forces to also help to develop that approach. There are different vendors. Most of them are competing in this or another way, but they come up the great idea and then do the implementation. Actually, it's all operational today, so you can use this platform, OpenDaylight platform, for your own development. So if you have a quick look on the inside, what's covered by OpenDaylight, actually there is a southbound API, which is OpenFlow 1.0. Actually now there is a 1.3 as well. You can talk to different vendor, different infrastructure pieces, whoever talks OpenFlow. There is a bunch of helper functions or helper application support or helper functions, most of them, which do some abstraction, which do some topologies, which do some rule management. And there is a northbound API. So there are two of those, which are presented to different applications, which you can create by yourself. So they are either RESTful or OSGI. So OSGI is Java-based interface, essentially, or Java. So it's gateway, to be more precise. So where you can wander and change your code or upload and download and attach your services. So it's rather dynamic and really helps to do quick or agile development without any restarts or startovers. Obviously, Cisco had some pieces around it for make it enterprise ready, but I don't go too much of details over here. So what you can do with this platform or this approach is a bunch of different functions. So the most simplistic ones are either forward or drop. If world would be that simple, that wouldn't need actually that big of the infrastructure for the simplistic tasks. But there is a different kinds of packet manipulations or flow manipulations which you may utilize for different purposes, which I will describe just a bit later. So first you can mangle with VLAN IDs. So as you are not networking people, let's say that this is a virtualization layer inside the networking app for sake of simplicity. We can also change of addresses, different levels. The MAC addresses on the really low level where the Ethernet is running, or play with IP addresses, which is probably more commonly known to each and every IT person. We can play around with service quality, type of services, stuff. We can play around higher ports in IP stack, TCP ports, UDP ports, etc. And we can change packet forwarding or packet flow in terms of next hop, where it's sent from one networking device to another networking device. And obviously, there is option to send something to controller. If you need some extra smart processing, that's also the option. So here's our demo use case, which we have prepared. So let's go and discuss this a bit. So this is a kind of classic enterprise deployment. There is a bunch of workstations, and there is a bunch of resources, your services, your applications, which end users use, and there is a bunch of networking stuff in between. So each decent enterprise has some security controls and measures in place to monitor the traffic, observe some strange behaviors, do some further analysis. So it's usually done in two phases. There is a first phase, which is a machinery phase, when there is a smart algorithms and different rules and all the stuff which correlate to events or happenings or packets or flows or whatever they do. And if this guy does some triggering, I found something, then usually it's a secondary phase kicks in. It's either more valuable or more expensive resource, like a human resource, kicks in and has a look at what's going on, make some deeper analysis, and hopefully gets back to the root cause, and then the process gonna go backwards in a sense. The root cause is gonna be hopefully eliminated, and that usually takes some time. What we can do here, actually, we can automate some of this process, and let's say the first kind of analysis is done by source file node here, who, if it finds something, can trigger the action in OpenDaylight controller, which in turn sends signals to network infrastructure that there is a specific need to do something. In my example here, it's going to be sending the same mirror flows which is sent to the intrusion detection system. It's sent to the human monitoring workstation, that very specific flow. How it's defined, it's obviously up to the signaling and up to the application which runs on top of OpenDaylight controller. What kind of traffic we do really need to send this specific monitoring workstation. So, just to give you an idea how it looks, let me show you. Here in the background, is, let's see, are the demo guard mercy for us? Let's see if we have connections. That's great. Here we go. So, like here, we have the OpenDaylight controller, and here we can have a look on network flows infrastructure. The infrastructure is yes, you don't see. I'm sorry. Just a moment. Let's view the view as well. No, you do. Right. So here is the OpenDaylight controller view. Basically, it's a developer view because end user doesn't touch that. And here you can see the network infrastructure which is taking part in this demo. So there are a few switches up here, and there are a few end nodes over here. And I'm gonna hit this 111 node and run a console from that. But before I do, I show you the flows which are currently in the network. And this is my switch 1, and it has at the moment 3 flows. Two to describe traffic between first and second node over here. And there is a special flow which I use to capture syslog messages, which currently simulate, but in real deployment it could just come from IDF systems. Yes?
Is a flow one concrete network connection, or is it a set of network connections in the same direction?
Right, it could be either of those. So it's based on definition what we define as a flow. So I can define a flow as a host to host, or host to service, or network to service. That's essentially how I define it. So it's not necessarily TCP session, if you think of that terms. It's rather definition who can communicate with who.
Excuse me.
Yes?
Do switches communicate to the controller in lifetime, or once in a while they...
Right. So essentially the control function depends. If there's a packet to be sent to switch, it goes live. For statistic collection purposes, for example, it's polled over the, by default, I think it's 30 seconds. But the control connection of switch kind of command the switches to do something, they go live in a sense. If the application in controller thinks there is a new flow to be programmed, it goes instantly. So it's kind of a combination. So the data plane actually works by itself based on flow definitions. What it has to do, it does by itself. But the new or updates to the flow definitions, those are pushed from the controller side. So if we need to do some changes, so for example, I'm going to show you just in a moment a change to the flows. Currently, as I said, we have 3 of those. At the moment, I'm running network. So if I do a ping over here, I can ping. I'm sitting from the host 1, so I can ping the host 2, right? And the third flow, as I said, is to kind of trigger something which was used to capture the syslog packets, and we forward the syslog package to the application sitting on controller. So we grab that, and there is an application on top of controller which makes decisions based on the syslog. So if I generate this syslog packets, there should be some change, which is following the scenario I described before. So that if there is a suspicious stream going on, SDS detects it and ask controller to do some changes, so other destinations can receive these flows as well. So as you see, there are at the moment 3 flows only running, but now if I generate one specific syslog packet, it's UDP 514. I just put arbitrary payload because I really don't bother at the moment that. Then we should see a change over here. So you see we have 4 flows now on the table. So there is a new definition from one host to another one, and there is a packet managing which says extra destination over here. So if you remember, there are actions which can be performed. There are a bunch of those. So you can remark, retag, rewrite something in a packet, etc. Right. So this command goes to the switches, and then new flow definitions are programmed over there. So the infrastructure will behave differently from that point forward, till somebody changes to, or tells them to change the new flows. So at that point, we're going to have extra flow going to the human analyst for specific inspection. It could be actually something other than human analyst. It could be a traffic logger where the space is premium. You don't want to log maybe everything, but just for suspicious stuff. You can control how long you really want to log. So you may say that this mirroring flow will be there for, I don't know, 5 days or 5 minutes, whatever you deem sufficient. It's all up to the application which is sitting on top of that. And in our case, this application is actually Java 1, so we choose that path, sitting on top of the controller. Other approaches, there is a kind of next generation software-defined underlay, software-defined network underlay, which tries to abstract even more. So, and abstraction actually goes to the level where most of the developers find it appealing. So essentially what is defined the whole application flow from the user in specific infrastructure till the data. So all the application tiers could have different rules in the infrastructure, what has to be performed at packet, either copied, restricted, remarked, policy enforcement, etc., etc. And this is defined really on high-level language, not a specific code as in my example here below. So this is actually the future where this is gonna go, and it's also supported not just one specific platform, but we see the whole industry moving that direction. It's not there at the moment. If you look on OpenStack by OpenDaylight, the ideas are there, the concept is written down. It's not fully implemented yet, but the full implementations are at the moment only the specific vendor space. So if you want to get it quickly, you have to choose some vendor to cope with. If you can wait, then you can wait till the platform is OpenStack/OpenDaylight are ready for that approach as well. So if we pick on task list or tools from the newer platform, there are more tools to be used. Specifically for user classification, there is a really variety till the user level integrations, not just IP or some strange deep nobody understands parameters. And also the action scope is gone much wider. So there are some interesting actions like no copy or no redirect. If you want to create really protected flows that nobody can capture or send through them some fooling algorithms, that's also possible now at the moment. So to put it all together, and this is specific vendor perspective again. So the framework is called One Platform, and there are different modules which talk to different southbound components. But for northbound, it's all unified. This is where the real development of application goes on. So you really don't care too much what's going down below. Is it the box yellow or green or of that size or that size? That's not of your interest. You want the function and policies to be possible to implement. So what those policies could be, there are a few ideas to think about. This is the one we kind of played through, not exactly, but similarly. So if you find something suspicious, you create dynamic mirror session for analysts. The second scenario would be data exfiltration. So if we see some strange behaviors like long sessions going to some places we don't explicitly whitelist, so we may be interested who is stealing the data from us, where it's going, so we can do things like slow them down, really to like a 3G speed or modem speed. So they are still with us. They don't see that we have discovered them, but we can monitor what they are doing and keep track on them. What else can be done is honeypotting. So if we, for example, observe some understandably malicious behavior, we can redirect the sessions to phantom networks, which looks like the same, but they don't contain any real data. They are all full of crap, so to say, so to kind of distract the attackers. So give them a lot of tasks to do, but achieving nothing. And this can be done in really low level by rewriting the MAC address layers or using different gateways for traffic. MAC address rewriting is probably the best one, or VLAN rewriting could be another approach to that. Another idea can be used is DDoS mitigation. So basically you have everything really dynamic. So if you observe the DDoS, you just one extra machine who can handle the load, and dynamically you can re-provision your environment based on security conditions. A few other ideas what you can do using different steps. First, you can use some tools to detect something. For example, NetFlow is well-known methodology or concept to collect the data. So that could be the case. So you analyze. If you discover something, you can say that please tag those stuff somehow so they are distinguishable. They are all the way the normal traffic is, but there is extra tags on traffic, so it's, let's say that's a possibly compromised workstation. Yes. Okay. So if this is observed that this workstation is possibly compromised, all the traffic is going through till maybe there is some really sensitive resources to which they don't get any access. So we have achieved kind of two things. If it's compromised, the guy who is owning it, he sees that everything works, but he doesn't get access to really sensitive resources. So there are really various ways to play around this infrastructure to make your life kind of safer, to minimize the life cycle from discovery of bad things or incidents till something is fixed. So for that, what you usually need is few components. So first thing you need the open APIs in the infrastructure, so you can talk to them, so they are not dumb boxes. Then you need some methodologies or some components which are almost ready-made or which you can build on, so you don't have to do everything from the scratch. And if you could put that all together, then you are essentially good to go, and you can just focus on the specific development of your application. So if that's interesting for you, here's a task list you can follow. If you are a kind of security guy, which I understand you are not necessarily are, but it usually goes that way, that you find your weakest link, you think, is there anything key that can be done on that? And then you can think of how it would be in ideal world. So what is your dream goal? So to say, you write it down, I believe, and then you have a cross-check what you have to achieve it. So is there anything you can reuse, or is it really greenfield, or can you do some brownfield stuff, so something old and something new? So it's all depends, as we say it. And then obviously you kick in and choose your platform or developer. Could be you, could be somebody who can assist you, who has some experience in this field already. You can say that we've got some experience. It's all very nice on the slides below. It's sometimes not that nice, but with some experience it's actually doable. And then obviously you have to plan some time for it. So it's not that quick as I demoed you, right? So, is there any questions left? Yes, please.
You had one slide about this DDoS. One slide you had this information of DDoS, and just the question is, nowadays the DDoS attacks are quite basic, I believe. But they are getting more and more sophisticated.
Absolutely.
Does this platform allow you to very also performance-wise efficiently already think about ahead and see be able to specify that
Okay.
to monitor and also react on
okay. The monitoring should be pretty easy. In a sense, it's huge. You see it with your naked eyes, so it's possible to understand that to machinery. In terms of handling it, because all the network infrastructure essentially is silicon, which is reprogrammed and controlled. So from that perspective, you only have to choose the hardware platform which is capable enough to spreading hundreds or tens or hundreds or hundreds of thousands VMs. So I would say it's linearly scalable in a sense that all the traffic forwarding decisions are made in hardware, in data plane. So only the control plane sometimes says that, okay, there is something new, let's reconfigure something. Some balancing algorithms maybe will be changed during the action or this kind of slow processes. But the packet flows, they are all handled on hardware level.
It's usually the packet flow, if you have binary algorithm, sorry, your data doesn't really understand what's going on. Then you have to have a very several layers contributing to this detection.
Yeah.
The more sophisticated ones are like you can only detect it on application level.
Yes.
And you really, these networking elements don't have any chance.
Yeah, absolutely. That's perfectly correct. So the detection engine is obviously part of the game. So it has to be smart enough. But we can, in the same way, we can scale those detectors. It don't have to be the one which is huge. It could be, again, 20 or 100 or 500. So the load is all distributed between different detectors. So you have linear scalability there as well. Okay, I think we are done. Thank you all. It was our pleasure.